minus x squared plus 3x minus 5. This is just adding and subtracting like terms, right? What sign is out front? Positive. There's a plus. When there's a positive sign out front and you remove the parentheses, all the signs stay the same. When there's a positive sign out front and you remove the parentheses, all the signs stay the same. If there's a negative sign out front and you remove the parentheses, what happens? Right. Every sign changes. Every sign changes. Now you add up your like terms. Let's see, this and this. What does that give me?
2x.
Right, very good. This one and this one, what does that give me? Very good, excellent. And then 5 plus 1 is what? 6. 5 plus 1 is 6. Oh, look at number 15. That's a good one. 8x cubed y squared minus 12x squared y cubed plus 4x squared y squared. Okay, I'll wait till you get that down. Oh, you're still doing that? Right. Now, I have to factor this, don't I? And do you notice that there's a greatest common factor in that? Do you notice that? Yes. You always have to take out your greatest common factor first, don't you? It's called your GCF. Now, what I'm thinking is this. I'm looking at the 8 and the 12 and the 4, and I'm thinking, what is the biggest number that divides into all 3 of those? And isn't it 4? So 4 is part of your greatest common factor. Then I'm looking at the x, and you have to ask yourself, is x common? Yes, because the greatest common factor means that it has to be in every term. So if x is common, the way you do this is you take the smallest exponent on x. Because after all, that's all that you can remove from a term like this or a term like this. You can't remove any more than that. That's all there is. Then is y common? Yes. And the smallest exponent on y is 2. So that's your greatest common factor. And that's how to think when you're doing it. Okay, now here's what we're going to do. We're going to say this. We're going to make believe we're using the distributive property. This times something is this. What would it be? 2x. Very good. Minus this times something is this. Very good. Excellent. Okay? Plus this times something is this. This is so important. Some students won't put a 1 here. You know that. You know that some students won't put a 1 here. But the point is that when you use the distributive property and work backwards, you're supposed to get this answer again. And if that 1 is not there, you won't get this answer again. All right? Okay, I'm going to go to the other side. You have your running shoes on?